Now let's turn our attention to classification, another fundamental type of supervised learning. Classification is all about predicting a discrete category or label based on input features. For instance, consider predicting a person's gender using their height and weight as features. Here, the goal is to assign the correct label, which could be either male or female. This type of problem is common when the outcome is a category rather than a continuous value. Classification is crucial when you need to sort data into distinct groups based on characteristics. In order to train our machine learning classifier to make good predictions, we are going to need some training data. So, for our classification task, our model will be trained based on some training data, test and validation data that we know to be true and is clustered in certain ways. As can be seen in this diagram, our dataset shows a clear distinction between male and female points. ML algos find optimal separations. Because we only have two features, it is easy to visualize this data set in a scatter plot. In the future, we get a new point whose features, height and weight are known. Our machine learning algorithm will then predict what class this should be in. In this case, it predicted male. There are obviously instances where this dataset can be wrong, since there are women who are taller and bulkier than men. This example is simplistic and shows us that our predictions are only as good as our input data. Bad data will without a doubt lead to a bad prediction. We also have multiple labels, where an item has more than one label to it, hence the name. This can be seen within our diagrams on screen now. One of the bears could be within two or more categories, such as a red teddy bear being in the red category and the teddy bear category. That is all for this video. See you in the next one.